Hello and welcome back to the channel. In my last video you might have noticed that there's a comment at the top because literally the day after I posted that video there was an update to cosmic clarity that specifically changes how the workflow goes. So I have a quick video on how the new version works, and yeah, welcome back to As the Astro. So, cosmic clarity, before, you had to put non-linear data in it, so stretched data. So you had to do the background extraction, do denoising, and a few other bits and bobs. Do the stretch, then put it into cosmic clarity. That caused some issues if you ever tried to do star removal. I know I've gone over star removal in the previous video. We will go over it a little bit today. So basically the workflow has changed. We can do some photometric calibration first. We can then do a background extraction, but straight from the background extraction we can then move straight into cosmic clarity to do the sharpen, and then we can stretch the sharpened image and then do some of the other bits and pieces, and it kind of opens a couple of doors which you didn't have previously. So let's go through what's going to happen with that. So I'm going to work on something new because you don't want to see the same image being processed again and again. So here's one I took a while ago, M27. It's on one of my previous videos, so should be able to compare between that version and this version to see what it's like. I've done all the first two stages, so I've done the AS tap bit and I've done the stacking in SIRIL, and we've got our result file, our stacked image, ready to go. So first thing I want to do is pop it into SIRIL. So pop into SIRIL, find our project M27, and open the result. Now this has for the M33 I used 255, 255, 255 for the colour offset. This one I didn't, it's flat 128, 128, 128 for the red, green and blue. And it does put a slight green tinge on it, so if we go straight for an auto stretch it comes out horribly green, so we definitely need to use the photometric bit first. So image processing, colour calibration, photometric colour calibration. Again, it already knows whereabouts we are because it's stored in the fix file. Just hit OK. Bang, straight away. And it's noticed that it's flipped it as well. But that's fine. So then we can save that as results 2. Oh, fine, no, call it M27. Let's call it what we mean it to be, M27. There we go. And we can still save it as a fits file because it's going to Graxpert first. So we're going to hit save on that. I will change the home folder because otherwise it's going to keep pointing us back at SIRIL's going to keep pointing back at the wrong folder. We want it not to be in that. So let's load up our project file, M27. There we go. And that's got a default stretch in it of 10%, and we want to do a background extraction. So quickly, I don't think there's any problem with this one doing this straight away because there's absolutely nothing on the edges to indicate any kind of issues. No, all looks good to me. So we've already done as background extraction, but let's quickly flip through what we've got. Background, yeah, you can see a bit of a gradient there. Hopefully it'll come through in the YouTube compression, but there's his original, and there's his colour calibrated, gradient corrected. So we can now save that, but, and this is the fun part, we can go straight into cosmic clarity. So one thing I want to do is make sure this changes to 32-bit TIFF, because Cosmic Clarity only accepts TIFF files. Like it's TIFF and PNG, I think, but TIFF's probably the better. Save processed. We want to be in the input folder of Cosmic Clarity. M27 Graxpert is fine for the file name. So hit save and we're in there. Excellent. We'll leave Graxpert open because we want to try and do a denoise on it as well at some point. So now we can go to Cosmic Clarity and run it. As you can see, it's a fresh install. Re-downloaded it. So what's new? Well, rather than having to type everything in manually, there's now a little pop-up box. It's now version 4.1 as well. So you can select your options from here. This is pretty much what I was putting in. I think I had non-stellar sharpening set to 4 rather than 3, but default's 3. Let's see what she does. And again, I'm on my main PC, so this is fairly rapid. Excellent. So we should now have an output folder. Okay, so that's our finished, our sharpened image. So what we can do now is you've got two options. We can take a copy of that and we can run it back into the input again. Let's just cut the original output in a stage folder. There we go. So we've got us in input again, and we can then run the denoise. Again, it's a fresh install. So, and again, you've got a pop-up window this time, and everything looks the same as what I would normally put. So that's fine. We'll just let that run. So we've gone from SIRIL to change the photometric colour calibration. Then we've dropped straight into Graxpert to do a background extraction. From the background extraction, we've gone straight into sharpening, and we've got that as a denoise. But because Graxpert is available, we can also load our sharpened image from Graxpert. Doesn't that look pretty already? We've barely done anything to it. Oh, it's just blows my mind, Cosmic Clarity. And we can run a denoise in here as well, and then we can kind of play around with both and see which one we like. Denoise and algorithms are obviously slightly different. They're both AI generated, but they're slightly different. So sometimes you get better results with one than you will the other. So you swap between the two and see what you like. So this shouldn't take too long. Nearly there. None of my images are drizzled. They're straight from the camera. I have to have a chat about the camera actually, and why I chose it. So that's our denoised image now. So we can save that, save processed. We'll save that back straight into the M27 folder. M27 Graxpert, Sharpen and Graxpert. I think we can work out what that means, don't we? In fact, let's save that back as a fits file, because we prefer working with fits files if we can, but obviously so we go down, and then we want to take the output of that one and drop that into our project folder as well. So we've got a couple of ways of playing around with it. So paste that there, get rid of that one because we don't want to get too confused about whereabouts we are. So we've got one that's denoised in Cosmic Clarity, and we've got one that's denoised in Graxpert, and we can play around with the two and see which one we prefer and stuff. So back into SIRIL. Let's open one of those up. Let's start with the Graxpert one. Okay, do an auto stretch. Yeah, kind of expect that from an auto stretch. it blows it out a little bit too much. But see how many stars are in that? It's just mental. So we've got an option here to do something called star removal. Now you might ask, why would you want to remove stars from your image of space, your astro image? And the answer is you sometimes you might want to remove them and put them back in again, but you do that so that you can emphasize the main thing you're trying to look at, but then still have a star field in the background. That's the reason why we do it. We run cosmic clarity this way as well, because before I couldn't do the star removal. There wasn't a kind of a slot to fit it in, and if you did it after the stretch, it mucked up the colours, and if you did it before the stretch, it mucked up cosmic clarity. So it's where did you squeeze it in? So let's do that. So all we have to do is, if you go to image and star processing, we've got the star processing utilities. We've got something called StarNet star removal. I think it's a separate thing you have to install as well as SIRIL, but again, it's a free thing, so free's a bonus. So we hit StarNet star removal. Do we want to do it? Yes, we want to do it. Because we're now working on a linear image, we want it to for the StarNet star removal, we'll let it do a little pre-stretch, and then we can hit execute. And it doesn't take long, and what we should get back is it will create two files but open up the file with the thing we're trying to look at in it. So it shouldn't take long. There we go. So here we have our background, our main item, M27. Absolutely no stars in it whatsoever. We like that. So what we're going to do is we're going to stretch this out. So exactly the same process as we did before. The black point is going to be well down at the bottom somewhere, so that's there, and then start with our little stretch. Now this is incredibly easy to blow out this, so we want to be super careful that it's not too bright. And if we modify the local stretch intensity, we can kind of stretch it that little bit more without blowing it out too much. Okay, let's see what that looks like once we've adjusted the black point. So we go back to linear, I'm going to slide that across, get that down, watching that clip as we did in the previous video, just to the point where we start clipping data. Don't think that's too bad. So let's apply that, close that. Let's give it a bit of colour saturation to make it pop a little bit more. That doesn't look too bad to my eyes. Let's just try a little bit. A little more colour in it. Oh, no, not that much. Way too much. Perfect. There we go. So that is our stretched M27 dumbbell nebula. Now there's a bit of noise and stuff in the background, and we'll only worry about that when we reincorporate the stars again. So what we'll do, we'll save that. You see it's named Starless M27, so we know what it is. So we'll save that, and then we'll open up the Starmask, which is the stars within the image, and then we need to decide how much of this we want to stretch out, because we obviously want to see stars in the image, but we want our main thing to kind of pop out as. Now the background is really black, and there's only a few dots of stars, so the symmetry point's a bit pointless because you can't really find one. We're just going to do all of it and then just start gently bringing some of the stars out. I think that looks good there. You're starting to see some of the blues from the stars which are actually in the nebula itself. I think that looks pretty good. Let's see if we can give it a little bit of colour. Does anything... Yeah, that's not bad. Again, this is very quick and dirty, but it's just to kind of give you a feel for the new workflow. So I think that looks pretty good. So let's save that. So we've now got we've got an updated Starmask and an updated Starless. So then if we go back into image processing, go to star processing and star recomposition, we can select the two files. Here they are. So on the background stretch parameters and the star stretch parameters, the background is the Starless, and the star stretch parameters is the Starmask. Oh, look at that, doesn't that look good? So I don't think we need to modify these stretches at all. I think that looks pretty good on its own. So we can close that. Do we want to give it any... We could try and throw it through a noise removal again. So let's save that as, again, a new file, because otherwise it'll call it this. So we want, let's call it M27 stretched. Oops, not MS27, M27 stretched. I mean, to be honest, I think that looks pretty good on its own. I don't think it... I'd be happy with that as an image. The colours have all got... stars have all got a bit of colour in them. The Dumbbell Nebula itself's looking pretty good. I'd be quite reasonable with that, happy with that as an image. But let's see what happens if we run it through a denoise again. So let's try it in Graxpert. So let's load an image. M27. We want as stretched version. This might look horribly blown out because we don't need to do that. Let's just run a denoise over it and see what it does, if anything. It might not do anything, but it might make it a complete mess. We don't know. We can only see. We get a lot of this noise in the background because of how much we've stretched the nebula compared to the rest of it. Basically, we've stretched the nebula quite a lot, and the stars we haven't stretched as much. But you can still see there's a where M27 is in the sky. There's a hell of a lot of stars in there, and it's very pretty. Nearly there. Is it any better? I wouldn't say it is really. So the question is it actually noise? It does appear to have some kind of structure to it, doesn't it? Well, okay. Let's say that that's okay anyway, because I don't think it's the noise reduction hasn't really done anything. So the question is that actually noise, or is it part of the structure of the image? And I say it's quite acceptable. But what we did do before is we had another version of it, didn't we? We had that version, which is it stretched and denoised through Cosmic Clarity. So we've already done the version that's through Graxpert. Let's do the version that's through Cosmic Clarity. So same thing again. What we're going to do first of all is we are going to do. Let's just do a quick auto stretch. Yeah. Do you want it that way? That way? That way? I think that way looks better. Okay, so let's get rid of that, and let's do same thing again. Star processing, StarNet star removal. Let it do a pre-stretch. Hit execute. Well, this is running its process. So the difference in what's happening with Cosmic Clarity is you now can run linear images through it. Before you couldn't. You have to stretch them. But we just put linear images in there now, and you can do different things. Okay, so let's go to the stretch again. Select that symmetry point. It's not far off the front of the end of that anyway. Let's give it a little stretch out. So we can stretch things a little bit more and then still maintain some of the image. And it's all guesswork really. It's like, you know, how does it? What do you think it looks like? Does it feel any good or? Let's see what that looks like. So again, apply that stretch, pull it back down again. That looks pretty good. Get some colour saturation. I think that colours come out a little bit hotter than what it does through Graxpert. That looks good to me, and we need to save that. Now, save button's not open, so let's just make sure we get the right one. So these are the new files, so make sure that name matches the name you're going to save to. If you can't hit the save button, just make sure you save to the right one, because you don't want to overwrite the Starmask. So you remember that this is the Starless and that's the one you want to save over, and it'll warn if you want to replace it, and yes you do. So let's open the Starmask, and again, looks pretty good. Let's give that a little stretch. Again, I think the data's pinned all the way to the left, so there's no point trying to select a symmetry point, because you might as well just start and then blow them up. So let's get to the same point again. Okay, so one thing we've noticed here is in the Graxpert denoise, when we came to this point, the stars had a lot more colour in them, and the Cosmic Clarity denoise, there isn't as much colour. So they've both been sharpened the same way, so exactly the same way, but this one there isn't as much colour in the star field. But again, you just want to stretch it until you think it looks pretty-ish. That'll do, and try and give it some colour saturation, but I don't think it's gonna. The only thing it's going to affect is right in the centre here. And you've got some reds and some blues, but most of the other stars are just white, or appear to be. So that's fine there. We can save button's active, so we can just make Starmask. Yeah, save that. Image processing, star recomposition. That wants to be our Starless. So it's the Denoise one. If you sort them in date order, in time order, that probably helps. So yeah, Starless on the background, and Starmask on that. Again, I think that looks pretty good. I quite like that. And I think all this other background stuff, I think, must be structure. I mean, to be honest, I've not noticed it before, so it's the first one for me. But I think all this appears to be background structure, so we're gonna leave it like that. I think. I don't think there's any real reason to try and. I mean, obviously, the denoise didn't work to try and remove it anyway, so. So yeah, so let's save that one as the final file. So let's call it M27 stretched. I'll call this one CC because it was the Cosmic Clarity denoise, and the other one was the Graxpert denoise. So again, we'll save it as a fix because if we want to go back to it and do anything with it, it's probably the best thing we can do. And then we'll save it as a JPEG as well, so we can have a quick look between the two. And then let's open the previous one, and let's do the same. We've already got it as a fix, so let's just save it as a JPEG, so we can flick between the two. So let's have a look. What do we have? So you can see them. So this is denoise from Graxpert, and that's the denoise from CC. The stretch factor is a little bit different, but then it always will be. I think both of those are pretty good. I think I might like that one, but I think that's more to do with the way that I stretched it. I think the star colours are actually about the same. You guys be the judge. I still think it's a bloody good image, to be honest. But yeah, so that's the new workflow process for the new version of Cosmic Clarity. As I would do it, AS tap first, sort the images, which ones want to use, don't use, SIRIL, Photometric, that's all we really want that for initially. Pop into Graxpert, do a background extraction, save from Graxpert straight into Cosmic Clarity as a TIFF file, immediately run the sharpening on it, take the output of that, either put it through Graxpert to denoise it or use Cosmic Clarity to denoise it, load both either back into SIRIL again, and then you can do whatever you want them. The reason, let's do a stretch from that one. So this is the This is straight from Cosmic Clarity sharpened and then into Graxpert to be denoised. Let's show you what happens if you don't do the star removal. So you start off with the same kind of process. If you don't do the star removal, because you're doing everything to get to the point where you've got it's like the stars kind of overpower the image, so to speak. So you do a star removal and a re-injection just to make the thing that you actually want in the middle to really pop out. Yeah. I mean, I don't think that's a bad stretch, and you can see the black point back down again. mean, that's just really quick and dirty, but let's just say that as a JPEG. And if this should flick between all three now. So that's the, so that's the one where it's one image and we've stretched it all together, and then that's the M27 stretched with denoised with Graxpert, and then that's the one that's denoised with cosmic clarity. I think the only thing between the last two is how much I've stretched it, and as you saw, it was really quick. So, so yeah, there you go. I do prefer the new version of cosmic clarity, being able to do it to the linear files than on stretch files. It works so much better. Anyway, thanks again for joining me. Please subscribe and like, and do all the YouTube stuff, and we'll catch you in the next one. Cheers, bye.